Okay guys, so with this video you are going to use your graphing calculator for the very first time. If you have your own, that's great. Take it out, you're going to follow along, press all the buttons that I'm going to press. If you don't, you can still follow along, still see what things are going to look like when we work with these in class. And you can also refer to this video whenever you're using the graphing calculator, anytime in 1.5, and you may forget what button to press or just what your screen needs to look like. So this video will be up for a while so that you can see what you need to do. So 1.5 is all about finding this thing called a line of best fit. Okay, so what's going to happen is you're going to be given a set of data like this below. We have our independent variable is the minutes that we might spend running. So we've got some various amounts of time there. And then what's associated with that, our dependent variable would be the calories that were burned. So that makes sense. The longer we run, the more calories we burn, so the calories burned is dependent on how long we run. And I first want to just make a quick scatter plot. So a scatter plot is just a set of points on an x and y axis. So everything's positive here, so I'm going to just look at this first quadrant in the coordinate plane. So here's our x-axis, here's our y. I got to get out to 23 on the x-axis, so I think I might count by 5s. And then I got to get up to 231, so I think I might count by 50s here on the y. You might count by something else, which is fine as long as it's the same as you go up the x-axis or the y-axis. We're just going to estimate where these points would be. So 5, 47, it's about right there. 9, 95 would be about right there. 14, 133. 20, 196. And then 23, 231. Okay. So hopefully your scatter plot would look something like that. If you need more time, you can just pause the video, finish up your scatter plot, and then restart it when you're ready. When you look at that scatter plot, you can see that the data points, they're very close, not perfectly close, but very close to being in a straight line. Which means that there is some line that gets as close to as many of the points as possible. So you don't have to draw that line in. I just wanted to show you. There would be a line that would get really close to most of those points and perhaps even go through some of them. And we know that straight lines, they're linear and they have equations. Now the great thing is our calculator can find the equation of that line that gets as close to as many points as possible. So, take out your calculator. Okay, I'm going to put it right there. I think you'll be able to see it. And we first have to tell the calculator what our data is. This is our data right here. We're going to have to enter that in a very specific place. Now, there might be old data in there, so we want to clear that out. To clear out your data, hit the second button, that yellow button, then hit the plus sign. And it brings up this menu. And we're actually going to choose option number 4. It says clear all lists, and you'll see why that makes sense in a second. You can either scroll to it with this arrow button right here, and then hit the enter button at the bottom, and then hit enter again. When you see the word done, it means it cleared out all the old data that might have been in your calculator. Alright, then we're actually going to enter the data. So this stat button right here in the upper middle of your calculator, we want to press that. And we actually just want to hit enter right on number option 1. It says edit. And when you do that, it brings you to these lists. So now it makes sense, clear all lists. It was talking about the whatever numbers may have been in here. And you want to remember that in L1, we are going to enter our independent data. So if you were in L2, just scroll to the left with using that arrow button, and I'm going to put a 5, and then I'm going to hit enter. I'm going to put a 9, enter, 14, enter, 20, enter, 23, enter. And then I'm going to hit the right arrow button because in L2 we're going to put the dependent variable values. 47, 95, 133, 196, 231. So you always want to make sure that you didn't forget anything. I like to see that I end on the same row there. And now we have the data in the calculator. So to find this equation of that straight line that gets as close to those data points as possible, we are actually going to hit stat again, but this time we're going to scroll to the right where it says calc. Lots of options in here. As the year progresses, you're going to find out what most of those mean, but option 4 is what we want. Lin-reg. That stands for something called linear regression. Okay, we want to find the equation of this linear relationship, so we're going to choose option 4. Again, you can either scroll to it or just hit the 4 button and hit enter. And just like before, you're actually going to hit enter one more time to run the application. And you get this screen with all these numbers. Okay, so you may not see r squared or r on your calculator. That is okay. That's a setting that I'll change in the next couple days. But everybody should see a and b here. A equals this long number, it's b equals that long number. And right above it says y equals ax plus b. That should look really familiar. That looks a lot like mx plus b, except they're just using an a. So let's go ahead and come down here and record our values for a and b, because those are going to be important. I usually recommend that we just round to 2 decimal places. So that's what I'm going to do right here. Now, those numbers are important, but that's not the equation of our line. We actually just want to plug those in to the appropriate spots. So A, this 9.95, we're going to put it right there into that equation. And B, negative 0.87, we're going to put right there into that equation. And that means that that equation that I drew in pencil above for that line would be 9.95x, in this case minus 0.87. I always like to make sure that it makes sense. This equation has a positive slope. Well, it's pretty clear that whatever line was going to go through those points was going to have a positive slope. It's also pretty clear that my y-intercept, it would be pretty small. It might be positive and close to 0. It might be negative and close to 0. In this case, it is actually negative, but still very close to 0. So the numbers actually make sense, which means I didn't mis-enter anything. I did everything most likely correctly. And that is how we find that equation that gets as close to those points as possible. All right, again, like I said, you can, pause this video, practice, rewatch it, whatever you need to do. And we're going to be practicing this a lot in class, so if it still feels a little difficult, don't worry.